Here's another application of infinite geometric series. So you know that some decimals just repeat over and over and over again. It happens when you divide two integers and the denominator is not a multiple of 2 or 5. If you have some multiples of 3 or some other primes in the denominator, you end up having digits that repeat. And there's even a symbol for it. If 2525 repeats over and over again, you write it as 3.25 with the bar over the 2 and 5. What if you just had 3.25 bar? What would this be? 3.2 and then 5. Right? Okay. So that you should know what this means. And we're trying to do the opposite. What were the two numbers that you divided to create this number as a decimal? What would that be? Okay, so here's how you approach it. Solution. You rewrite 3.25, 25, as 3 plus 0.25 plus 0.0025 plus 0.000025 and so on and so on. And then you write these as fractions. So it's 3 plus 25 over 100 and 25 over 10,000, 25 over a million, so on and so on. Oh, but by the way, you don't really have to convert to fraction if it's a little challenging. You can just rewrite it as like 0.25 times 0.01 would be the next one. This times 0.01 would be the next one. So you can use decimals as well. You don't have to convert it to fractions. But once you write it like this, you realize that except for 3, if you just think about this point and onward, that's a geometric series because every time you go to the next one, you have to multiply by 1 over 100 to get to the next one. 1 over 100. Multiplying this by 1 over 100 will give you the next one, and so on and so on. And therefore, you can use the formula. What's the formula for infinite geometric series?
A over 1 minus over.
A over 1 minus. Okay, so in this case, well, 3 is 3, but for this geometric series, what's A?
First number 3.
No. 3 is not part of the geometric series because 3 times 1 over 100 doesn't give you that. So this one breaks the pattern. So that's why you have to break this off and just think about this as an infinite series.
So it's 25.
25 over 100 would be the very first term. Okay. And then, what's the common ratio?
1 over 100.
1 over 100. So it's 1 minus 1 over 100. And then you can calculate this, but the quickest way to simplify this would be multiply 100 top and bottom. You can do that, right? For a fraction, if you multiply the same number top and bottom, it doesn't change the value. And then it becomes 100 and 100 cancel, so you have 3 plus 25 over 100 times 1 is 100. And then 1 over 100 times 100 would be 1. So you get 3 plus 25 over 99. And you can make this a common denominator by multiplying 99 over 99. 99 times 3 will be 297. 297 plus 25 will give you 322 over 99. Okay. So that's how you represent a repeating decimal by ratio of two integers.